Okay, hello everybody. Hope you're doing okay today. So we are going to start into Chapter 6, Section 1. And Chapter 6 has quite a few different topics in it, but this Section 1 um, is going to study a linear systems of linear equations. And so you can see in front of us there, we have two objectives that we're going to be looking at today, which the first one is determine the number of solutions that a system of linear equations has. And then the second objective is going to be to solve that system of linear equations by graphing. So let me explain to you what a system of linear equations is. What you see in front of you is a little chalkboard, and you can see that there are two equations written on there. You have this one right here, which is x plus y equals 7, and then you have this second one, which is x minus 2y equals 1. What a system of linear equations would be is it would have a grouping around those, which would tell us that both of these would need to be graphed on the same set of coordinate planes. And whenever we would graph these on a coordinate plane, both of these equations, we should get two lines because, as you should know, those two equations are both in standard form. Remember, standard form is ax plus by equals c. We also have slope-intercept form, which is y equals mx plus b. And so those are the two main forms that we're going to be focusing on in this section. But if you were to graph both of those linear equations in the same graph, you could get you're going to get two lines. Now, depending on what those two lines look like, will depend on what we would say their solutions are. So there's a couple terms here, and they explain what they are. Now I'm going to go over those in 1 second. I'm actually going to flip forward here to show you what could happen whenever we graph two lines. So in this first example that you see right here, when we graph these two lines, they are two separate, totally different lines. And because their slopes are different and their y-intercepts are different, they end up intersecting in one point. And so for these systems, when we're looking for a solution to the system, the solution occurs where one or more of the points of intersection. So in this case, there's only one point of intersection. Now, if you look in the second one, this is actually a graph of two different lines, but they are the same line because they're graphed on top of one each other. And so what that means is this does not share one point in common. The two lines share all of their points. So in this case, there would be an infinite number of solutions. Whereas in our first case, the one with the star by it, there would only be one solution. Okay. Now, in the last case, you can see what we have. We have two different lines, but those two lines are parallel. And because those two lines are parallel, they will never intersect. That's actually the definition of parallel lines. And so, again, a solution to the system is where the two lines cross. If the two lines don't cross, such as we have in this third example, then there is no solution. Okay. Now, let's talk about why that happens. Before that, I want to scroll up here and look at these real quick. So the solutions, there's three types of solutions. There's independent, which is when there's one solution. There's dependent, when there's infinitely many solutions. The lines are the same. And then there's inconsistent, which means no solution. So as I scroll back down here, then this would be called independent. The second one would be dependent. And then the last one would be called inconsistent. And so that's what the three different solutions will look like. And that's the name of them. So let's talk about why each of these happens. So if you look in this first graph here, you can see that we have two separate lines. And remember, the main form of a line that we want to talk about is y equals mx plus b. The two important pieces of information in that equation are going to be the slope and the y-intercept. And if we look at this, these two graphs, let's start with the y-intercept since we call it the beginning or the B point. So if I look where this y-intercept is, this y-intercept is way up here, and then the y-intercept of the other one is way down here. So you can see the y-intercepts are different. And so that's what I want to say right here. B is different. Okay, now if I look at my slope, this slope is a positive slope. This slope is a negative slope. So inherently, because one is going up and one is going down, those are also different. So when I look at the slope here, the slope is also different. So you can see when there is one solution, what's going to happen is in the equations, the m's will be different and the b's will be different. Now in this second example, if I look at this, you can see there are two lines here. There's a line here, and then there's one right on top of it like that. So as I look at that and I think, okay, well, what about the M and what about the B? So the B, they're both crossing at the same place. So the B's on those two lines are the same, as is the M. The slope is the same on both of those lines because they're the same line. So when you have an infinite number of solutions, that means that the slope and the y-intercept will be the same, or vice versa. If the slope and the y-intercept are the same in your two lines, then there will be an infinite number of solutions. Now, in this last example, you can see that we have two lines, and we need to look at the M and the B in these. So here's the M and then the B. Now, if I look where the B's are, the B is the y-intercept. The y-intercept for this line is here, and the y-intercept for this line would be all the way up here. So they clearly have different y-intercepts. So this is going to be different. But if you were to count the slope up, you can see this one, we would go up 2 over 1. If I start here and I go up 2 over 1, it lands me right back on the line. So both of these have a slope of 2 over 1. So their slopes are the same. And so in the case when your y-intercepts are different, but the slopes are the same, that means you will have an inconsistent system and there will not be a solution because the lines are parallel. So using all of that information that we just wrote there and using those tables or the graphs, we're going to go down here and we're going to talk about, we're going to kind of organize that data into a table. And you can see right here, we have an M and a B and a number of solution. So this is exactly what I just wrote up here in a table format. So if the slope is different, then the y-intercept could be same or different. It actually doesn't matter in this case. That's why they left it blank. There will be one solution. If the slope is the same, but the y-intercepts are different, then you're going to have parallel lines. In the last case, if the slope is the same and the y-intercept is the same, that means we have the same line and there's an infinite number of solutions. So now let's use that information to answer these questions. It says number of solutions. Determine the number of solutions each system has. Now, in order to do this, we need to know what the M and the B are in our lines. So in this first one, it's really easy to figure out because when I write y equals mx plus b right here, you can see that it lines up very nicely with slope-intercept form. So in this one, the m is 1 and the b is -1. Now in the second one, y equals mx plus b, you can see the m is -1 and the b is +1. And so now comparing those two, these two are different, these two are different. So both our slope and our y-intercept are different. Both the slope and the y-intercepts are different. So if I go to my table and I say the slope is different and this is different, and the b is actually not going to matter no matter what if the slopes are different. If b is same or different, it doesn't matter. You will have one solution. So in this case, then, when we scroll down here, there is one solution. Now, looking at number 2, the first one is in standard form. So we need to get that into slope-intercept form by subtracting x from both sides. So I end up with -y is equal to -x minus 4. Then I divide by -1, and I get y equals x plus 4. Okay, now if I look at this equation, and I look at this equation, the m is 1, and the b is 4. In this one, m is 1 and b is 4. So you can see both the slopes and the y-intercepts are the same and same. So I don't even know if we need to look at the table for this, but we will. If the slope is the same and the y-intercept is the same, it means we have an infinite number of solutions because it is the same line. So there you go. That is infinite number of solutions. So we're going to look at 2 more of these. So this is number of solutions. Determine the number of solutions each system has. So once again, you can see the first equation is in slope-intercept form. So we can write m is 1 and b is 4. In this second one, we need to get it into slope-intercept form to figure out what the m and the b are. We're going to do that by subtracting 2x from both sides. And then I'm going to divide by -2, like that, and I get y equals 1x minus 1. So in this one, m is 1, b is -1. So looking at my m's, the m's are the same, but the b's are different. So going up to my table, if the slopes are the same, but the b's are different, those lines are going to be parallel, and there will be no solutions. So we will say parallel lines. Oops. No solution. Okay, so the last one we're going to look at today, same as the others, we're going to write what the m and the b are. In this case, the m is 2 and the b is -3 for this one. Y equals mx plus b. You can see how it nicely lines up with slope-intercept form. But this second one is also in standard form, like it was in the last problem. So we need to move the 2x to the other side. And then I'm going to divide by -2 again. You'll see I'll get y equals 1x minus 1. So this one has an m of 1 and a b of -1. So y equals mx plus b. So m is 1, b is -1. The m's are different. The b's, the b's are different. So m is different, b is different. If we go up here, m is different, b is different. Actually could be different or the same. It's going to mean we're going to have one solution. So we would come down here and write one solution. So there you go, guys. I hope that made sense. This is the first of 2 videos we will have on this section, and your next video will be tomorrow. So if you have any questions, feel free to email me. Have a great day.